Hello friends, welcome back to my Pandal Hub channel. Today we are going to look into the part 5 Java interview questions and mainly concentrated on the singleton design pattern. So let's get into it. What is singleton design pattern? Singleton pattern says that just define a class that has only one instance and provides a global point of access to it. In other words, a class must ensure that only one single instance should be created and single object can be used by all other classes. So in simple words, this singleton design pattern is one which has only a single instance of it. That is, if for example, if you have a class, then if it has to be a singleton, then in that case you will be able to create only a one instance of it, and that one instance is only used by all other classes. Even coming to that one instance, you will not be able to explicitly create it outside the class, but you have a public method inside the existing class which will just return the instantiated object to it so that you can use it. So there are two forms of singleton design pattern which you can use it for creating the objects. One is like the early instantiation and the other one is the lazy instantiation. So early instantiation represents the creation of instance at load time, whereas lazy represents creation of instance when required. So early represents you are going to have the instance instantiated beforehand, even before some other class needs it. But lazy represents you are going to create an instance only at that time when some other class is going to call that public method. So the advantage of singleton design pattern is it saves memory because it's in the place of creating a lot of objects for each and every request, only one object is used, uh, which will help us to save the memory. And the places where the singleton design pattern is mostly used is the multi-threaded applications, database applications, and sessions. For example, in a single session, you want to perform different transactions. In that case, you can go for the singleton class. So it is used in logging, catching, thread pools, and configuration settings, etc. And how to create a single design pattern. So the first thing what we need, the main three things that we need for the singleton design pattern is that one static member, that is, it represents the instance of the class. So the instance or the object of the class should be declared as static. So only then you will have the class scope and you can access it using the class name also. So the private constructor represents the constructor of the class of the singleton class should be private because only then it restricts the creation of the objects outside the singleton class. So if you have a class employee and you have a class department, and the department class and the employee class both are going to access a singleton class called session. So in that case, both the employee and the department class will not be able to create an object for the session singleton class because the constructor is private. So this constructor being private restricts the outside classes to create an instance for this singleton class. So static factory method. So this provides a global point of access to the singleton object and returns the singleton class instance to the caller. So I said the outside classes will not be able to create an object. So how are we going to get the single instance of that singleton class? So inside the singleton class, we have the static member, that is a static object variable created for the singleton class, and we are going to have a public static method like a factory method which will return the static instance of the singleton class we have created in that singleton class. So, let's look at this example. It will be easy for us to understand. So I have a class sample which I am designing it, or I'm creating it as a singleton class. So static variable, that is here static variable in sense the private static. This is the class, the singleton class sample which I'm creating, and I'm creating an object for that sample class. That is a singleton class. So I am making this class object instance to be static because I want this to have a static scope, that is a class level scope. Okay, so that it gets into, since it's a single instance, right, it just directly gets into the memory directly, and it gets loads only once since it's a static. So I just made it static, and going with the private constructor, I have made the sample, which is the class name, the constructor to be private so that the instantiation of the object of this class is restricted. And then I have the static factory method, that is nothing but a static method to get the instance. So public static sample get instance. So this is the method which is accessible to the outside classes which I mean outside classes which want to use this singleton class. And the same way, this is the same example here. So the difference between these two codes is that this, the first one, I have done an early instantiation. That is, the object of this class, the object of the singleton class is instantiated at the time of creation itself. So whenever an outside class is going to access the singleton class object using get instance method, the object will be returned. Whereas considering the lazy instantiation, here at the time of object creation, I haven't instantiated the object. Instead, what I have done is inside the static method, I have just checked if the object is null. If the object is null, only then I'm going to instantiate it and then I'm going to return it. So here the object creation of this singleton class is done only at the time where the outside class is going to call this get instance method of the singleton class. So this is a kind of lazy instantiation. So challenges in singleton design pattern. So what are the challenges that we face in the singleton design pattern? So the only motive or the only the only thing of the singleton class is that we should have only a single instance at any point of time. We should not be able to create more than one. So that is the only design pattern or the criteria of the singleton design pattern. So we have to check in all the possible ways whether there is one more instance being created, so that if more than one are created, then it's useless going for a singleton design pattern. The name itself says it's a singleton and it is being made void there. So one of the key challenges we face is how to keep singleton class as singleton. That is how to prevent multiple instances of a singleton class. So this code of version 1 creates multiple instances if two thread access this method simultaneously. So this was the code which we checked, which we saw for the lazy initialization. So we are going to have a static variable that is a static object for this singleton class, and we have a private constructor. And here in a public static method, what we are checking is if the object is null, then the instance is being created and it is returned. So when we check this public static method of get instance, when two or more threads access this method simultaneously, so there are many chances that more than one object gets created. So the meaning of singleton class is being void here is denied. So there are more than one objects being created. So how could we avoid it? So one solution here is using synchronization. So synchronization, we are very aware of it, right? This definitely makes the code thread safe and creates only one instance of singleton class in concurrent environment. So what the people say is when you make this method to be synchronized, so in that case, it's one of the solution for us because only one thread can access this method at a time because the because since we added this synchronize, this complete method becomes thread safe now. But it could be expensive due to the cost of the synchronization on every call. Because if, for example, if there are more than 5 or 10 threads accessing this method, then all the other threads have to wait until the lock is released by the previous thread which has acquired the lock. So in that case, it could be expensive because the whole method is being synchronized. Okay, so, and one more point here is when we do have an instance and when there is no necessity to create an instance, the thread will be blocked in the synchronized method for a long time until the other thread releases it. So inside the synchronous method, when you look at the logic, if the object is null or the object of this singleton class is null, if it is not instantiated, only in that case it is going to instantiate it and then return it. So for every first time we don't have the object being instantiated. So for the first time, this logic or the if loop or the if block gets true and an object is instantiated. But for the subsequent calls, we already have an object being instantiated and it is going to blindly return the object. Okay, so for the first thread, when it acquires a lock, it's going to create the object. But for the second thread, From starting from the second threads, we don't need we don't need this if block at all because the object is already instantiated and we just need the object to be returned. So we just made it synchronized to restrict the object creation, multiple objects created, multiple objects being created. So here what it happens is, even if the object is already available, other threads keep waiting for the lock to be released for this method. So this is an unnecessary wait where the other threads have to wait even after having the object being created already, which is already existing. So the next solution how we can overcome this is called the double checked locking. So the solution is using double checked locking. So what is double checked locking? Double checked locking of singleton is a way to ensure only one instance of singleton class is created through an application lifecycle. So this is a kind of a locking or a checking mechanism that only one instance is created for a singleton class, and and making the threads not to wait unnecessarily if the object is available. So in double check locking, what we'll be doing is the code checks for an existing instance of singleton class twice with and without locking to double ensure that no more than one instance of singleton gets created. So here what they are doing in the double check locking is, so inside this method, instead of making this whole method to be synchronized and the place where they are checking the object to be null, right? So inside the object to be null, first they are checking if the object is null here. So inside it, start. So start. So So start. So here in the double check logging, when we look at the code, so here what they're doing is, instead of making the whole method to be synchronized, they are just making a block of code to be synchronized. So inside the synchronized block, what they are checking is if the object is null, only then they are creating the singleton object. So outside that, they are having a one more object null check, because if the object is null, it's only for the first time that we face this. So after that, when the object is not null, we want the object to be directly returned. So only if it's null, it has to move on to the synchronized block. If not, if the object is already pre-existing, then it's just going to return the object. If not, then it moves on to the synchronized block and checks if the object is not null once more. And only if it's null, it's going to create the singleton instance. So since we have two null checks here, this locking or the checking mechanism is called, this locking mechanism of it, the logic is called as double checked locking. We have double null checks followed by a synchronized block, which is the locking mechanism for the threads. So intention is to minimize cost of synchronization and improve performance by only locking critical section of code, the code which creates instance of the singleton class. So as I rightly said, instead of synchronizing the whole method or blocking the whole method, we are just blocking a lines of code wherever the thread safety needs to be implemented. So only those lines of code are being synchronized instead of the whole method. By the way, this code is still broken. What? They say that even this code can be broken. If we don't make object volatile, as another thread can see a half initialized instance of singleton. So what does this mean is, they say even now this code can be broken on the version 3. So how it can be broken? So for example, I said that this synchronized block can be accessed only by one thread at a time. Okay. So when you have a thread, it has something called thread local. Okay, it has something called thread local. So what is thread local is, each thread has its own memory space where it stores the variable values which it is accessing at that time. So in that case, what happens is, each thread may have a different copy of it, and there may be a problem, or there may be an out of sync issues between different threads. So to avoid that, we want this variable, whatever the static variable, the object instance, whichever we have created, we are making it volatile. So what will volatile do is, when you mention a variable to be volatile, so in that case, what happens is, every time the thread reads the value of that object or a variable, it reads it from the main memory. It doesn't take its own copy. Okay, so all the threads which are accessing the variable, which is the object here. So every time this variable or the data is accessed, it is accessed from the main memory and not from its own copy. So this will help us to maintain what is a sync between the threads, and it gives more thread safety to us, so that it cannot be broken even in the case of a thread concept. So as I said, as another thread can see a half initialized instance of singleton. So that is when two threads are accessing. Sometimes, by the way, by the time the other thread comes, it may see the half initialized instance of singleton, not a complete one, or the one thread may take some time to update. For example, so one thread is accessing this synchronized block, and it is in the process of creation of this instance, and it leaves the lock, and the other thread gets the lock. And by the time the previous thread creates an object, this thread may not have any idea whether the object has been created or not. So it may in turn go and create one more object, or it can go and instantiate the object saying the object is null. So there are chances. That is when the previous thread takes some time to completely initialize the instance, and the second thread which gets the lock sees only a half initialized instance of a singleton, and it blindly goes and creates one more instance. So in that case, there are chances that there are more than two instances of this singleton being created. So for that, we are just making the variable to be volatile, so that every thread which accesses this object reads from the main memory. So what is volatile keyword? Just to know an idea, is that the volatile keyword does not catch the value of the variable and always reads the variable from the main memory. So it doesn't read it from the cache, but it directly reads from the main memory, as I said. The volatile keyword cannot be used with classes or methods. So this cannot be used with classes and methods, and they can be used only with primitive variables or objects. So the volatile keyword always uses main memory for variable values, so they can be used to modify the value of a variable by different threads. So since the variable values are stored in the main memory, all the updations or the read and write operations, everything is done in the main memory and not on the local copies, even the write operation also, I mean. So this makes the classes thread safe, where multiple threads can use a method and instance of the classes at the same time without any problem. So since the main memory is used uh, for accessing the values of those variables, so we by default get the thread safety, and we don't need to worry about it. So just to rewind, what we're doing is, to create a singleton design pattern, we just create a private volatile static variable of the instance of that singleton class, and we are going to have a private constructor, and we are just going to have a public static method to get or return the instance of the singleton class, so that it can be accessed by the outside classes. And inside that, we are going to have a double checked locking system. That is, double check implies we have a two double null checks for the object, for the instance of this singleton class, one outside the synchronized block and one inside the synchronized block of code. And we have the locking system. The locking represents we are having a synchronized block of code, inside which we are checking if the object, if the instance is null, and if the instance is null, we are going to instantiate it and we are going to return it. So this is the way where we write the singleton design pattern. Hope you guys have a good idea on the singleton design pattern now, and thank you so much for watching this video. Please do watch the other parts, and please do like and share and subscribe, and please let me know if you have any comments in the comment section. Thank you so much.